Hey guys, welcome back. Nachkazi here. In today's video, I'm going to talk about Cisco SD-WAN. You will get to learn a lot about how the Cisco SD-WAN solution operates. We'll do a deep dive into the architecture and the different elements of the SD-WAN fabric and how the different elements operate and come together to create this beautiful Cisco SD-WAN. It's the Viptela solution. It's not the Meraki. Just want to clarify that. You'll enjoy it. And if you want to learn about the fundamentals of SD-WAN or SDN, I will provide the links down in the description below. Are you ready? It's going to be an exciting one. I am super pumped. Let's roll. Let's jump right into it. Here's the overview of the different topics I plan on covering today. Number 1, Cisco SD-WAN architecture. 2, key design elements. 3, planning a migration. And finally, I'll wrap it up with a quick overview of the Cisco SD-WAN appliance portfolio. So let's quickly look at the Cisco SD-WAN architecture. At the heart of it, we got the underlay. And all the blue boxes that you're seeing on the screen are the routers, which we now call SD-WAN appliances. We used to call them routers, now we call them SD-WAN appliances because they're much more than your traditional routers because of the capabilities they offer. And then we have different transport. We could have MPLS circuits coming in, internet circuits, 4G, 5G, LTE, and all that. Combined together, they make up the data plane. And these routers or these SD-WAN appliances could be physical or virtual. Through the magic of ZTP or zero-touch provisioning, they can automatically come up, and we'll talk about ZTP in a bit. And they could be on-premise or in the cloud. So they could be physically located at our branch locations and data centers. They could also be located in the cloud. Or you can have a combination of the two. To the right of the screen, I want to draw your attention to the multi-cloud on-ramp. It's basically a performance measurement capability that's taken into account to find the best path to the different SaaS and IaaS providers. So SaaS being Salesforce.com and O365, and IaaS being AWS and Azure and GCP. And the idea is that there are constant HTTP pings and DNS requests sent to each of those providers to see over which path, assuming we had multiple paths to those providers, which path is performing the best, and then making sure that we use that path as primary. The second element, security. So security with the SD-WAN appliances could either be local or cloud-based. Because these SD-WAN appliances that Cisco offers have pretty robust security capabilities. They can act as a firewall for you as a single box solution, and we'll discuss more details in a bit. But you could do that either on the boxes, or you could redirect traffic through service chaining to the cloud for the traffic to be inspected. The last element here is the application QoE, or quality of experience. This is the secret sauce that comes with the Viptela solution. So Cisco acquired a company called Viptela a couple of years ago. They were SD-WAN specialists, and that's what gave Cisco the ability to have a very robust SD-WAN capability. And this quality of experience score is a combination of packet loss and latency. And it's measured for different apps over multiple paths. And once again, the idea is to identify which path is performing the best, has the least latency and the least packet loss, so we can use that as the primary. The next element in our SD-WAN architecture is the control plane. So remember guys, the whole idea of the software-defined networking in general is to separate the data plane from the control plane. Why do we want to do that? Well, the reason we do that is because it gets easier for us to deploy things. We don't have to touch each and every device hop by hop. We can do that centrally. That's why we want to take the control plane out and put it on a controller, which in this case are vSmart controllers that Cisco offers. These vSmart controllers communicate directly with the edge appliances at the bottom of the screen. And these vSmart controllers are able to push the routing configuration down, security configuration down, and they scale horizontally, which is basically a scale-out model, which means as you continue to add more appliances to your locations and as you continue to expand your business, you can spin up additional vSmart controllers to be able to handle the additional load. Because each vSmart controller can only handle so many SD-WAN appliances and X number of tunnels. The third element here is the management plane. And with the management plane, what you get is a single pane of glass where you can configure the entire environment, monitor, troubleshoot. What it is it's a portal. The customer can use the browser of their choice, Chrome or Safari. You log in and you get a nice GUI, and through that GUI, you start to configure devices. And there's like a one-time setup that you have to do the very first time you log into vManage, but then after that, you have to configure templates and things of that nature. But that's where everything happens. And then the role-based access control is also set up there if you want to give access, different types of access to different people within the organization. Some people read only, others read write. vManage also supports third-party automation. So if you have Chef, Puppet, Ansible, you can use those automation tools to feed the scripts into the vManage, so the vManage can then talk to the vSmart controllers to push the configs down to the devices at the bottom of the screen. So it's really, really interesting and cool. And then to the right of the screen, you see vAnalytics. That's another type of controller that allows customers to have deep analytics about the environment. vAnalytics uses ML or machine learning and is capable of analyzing the entire environment for bandwidth forecasting reasons and also keeping your service provider honest, because it tells you the uptime, the downtime. You can use those reports and talk to your service provider. vAnalytics also gives you some insight into how the applications are performing. The next element I want to draw your attention to is the different type of controllers that the Cisco SD-WAN has. So there are 3 controllers altogether. Like I alluded to a little bit ago, vManage is the portal that you log into, and this is where everything happens, right? This is where you configure everything. vSmart, you don't touch, but vSmart talks to vManage, and vBond also talks to vManage. vSmart is used to actually manage all the routers, and it uses OMP or Overlay Management Protocol that allows it to communicate with all the different SD-WAN appliances, and this is how vSmart is able to configure, all the routing and security and the different type of policies that you have set up. And vBond is the controller that's used to authenticate and authorize the devices so they can connect to the SD-WAN fabric. The very first time device comes up, it must talk to the vBond controller. And unless it's authorized, it gets rejected. And we'll get into some of those details momentarily, but these are the 3 different controllers that are part of the overall controller architecture. There are 2 deployment mechanisms. Mechanism number 1, less desired, is the on-prem controller model, where the customer takes these 3 controllers as VMs, and you can use the hypervisor of your choice, VMware, Microsoft, KVM, whatever have you. You can go ahead and run these as VMs. Not recommended though, because you have to worry about the infrastructure that it's running on, and then the VMs and the right amount of memory and all that. And then you also have to worry about redundancy as well. Creates more complexity in your environment. What's recommended is cloud delivered model, where Cisco deploys the controllers for you, and all you do is log in to the vManage portal and then configure your SD-WAN fabric. It's that simple. 99% of the customers go with the cloud delivered model. And just so you know, most of the SD-WAN vendors on a global scale offer cloud delivered solutions. Some do not have an on-premise capability. Something to keep in mind. Now let's look at the zero-touch provisioning, or ZTP, explained in 4 steps. Step number 1, when vEdge comes online for the very first time, okay, you unboxed it, you plugged it in, it first goes and speaks with vBond over DTLS tunnel. Okay, vBond is a whitelist model, and what it does is it looks at the serial number and the digital certificate it's already programmed with, and it matches the device's serial and the digital certificate to make sure everything matches. And if the private key matches on the digital certificate side of the house and the serial number matches, then it gets authorized, and the vBond then redirects that vEdge to the vManage and vSmart. However, if the serial number or the digital certificate do not match, then the device gets rejected. So that's an important step. Okay, so security is very key in this whole design. Step number 2, after being authenticated by vBond, once starts communicating with vManage, it establishes a DTLS or TLS tunnel with vManage. And just so you know the difference between DTLS and TLS, DTLS is for UDP traffic and TLS is for TCP. And assuming that we have already set up our templates on vManage, the entire configuration for that vEdge gets pushed down by the vManage controller like magic. And all of its interfaces come online, it gets configured, gets all the IP addresses, all the routing information, security, everything. Step number 3. What ends up happening here is that the vEdge starts talking to the vSmart. And vSmart, once again, there's a DTLS/TLS tunnel established. And what ends up happening is vSmart establishes an OMP session. And that's the overlay management protocol. That's a secret sauce routing protocol. Think of it as BGP on steroids. Because BGP does not carry security information, whereas OMP has the ability to carry security information along with routing information. So it's a lot more capable than BGP. And the final step, step number 4, is where the 2 vEdges start talking to each other over IPsec tunnel. Now notice the difference here. We're no longer doing DTLS or TLS tunnel. Now we're doing an IPsec tunnel. And another important element to keep in mind is there's a BFD session, or bi-directional forwarding detection session, established between the vEdges. And the reason for that is for a quick failover to happen. As soon as a path goes down, BFD immediately switches the path over in a sub-second. Now let's look at the Cisco SD-WAN key design elements. First off, let's look at overlay VPNs and topologies. So in this diagram here, we have vEdge to the left and we have vEdge to the right. In the middle, we have transport. And it doesn't matter whether we have MPLS, Internet, 4G, whatever, because remember the whole idea of SD-WAN is we're no longer dependent on the underlay transport. We could care less about the underlay. It's all about the overlay. Well, how are the overlays formed? Well, you see the ABC, these are the 3 different VPNs that are created. And VPNs are essentially VRFs or VRFs. These are virtual routing and forwarding tables. They're completely separate. These VPNs don't talk to each other by default. You can make them talk to each other, but by default, they don't talk to each other. So if you have some compliance requirements in your network like PCI and others, you can create a separate VPN to handle that traffic and create that separation and be compliant. And what's exciting here, guys, is each VPN can have its own topology. So here, for example, VPN-A, which is red, could have a full mesh. The green VPN-B could be a hub and spoke. And the yellow VPN-C could be partial mesh or point-to-point. So it gives you a ton of flexibility to pick a topology that best matches your business needs. Now, from a traffic engineering perspective, we have a couple of different options. Option number 1, which is the default option, that's active-active load sharing. Now, one thing to keep in mind, it's per session based, not per packet. So once a session is formed, either over MPLS or Internet, for the life of that session will always take the same path. But then when the next session is required, a different path is taken. So this is how the load sharing is accomplished. The next element here is weighted. So for example, if you have a 10 meg MPLS circuit versus a 100 meg internet circuit, you would want to send, for every 10 packets you send on the internet, you would want to send 1 packet on MPLS. That can be configured using per session weighted model. The next one is application pinning. Here, if you have real-time traffic like voice and video, you can always pin it to MPLS, regardless of how great internet is performing. Because you're paying a ton of money on MPLS, you may go, you know what? For my real-time traffic, I will always use MPLS, no matter what. And when MPLS goes away, then I would use internet as a backup. That can be done. The last one up is application-aware routing, and that's my favorite one. It's SLA compliant. SLA stands for Service Level Agreement. What that means is, under vManage, we configure a policy for our voice where we say we cannot go below a certain threshold, and we define that threshold, latency, jitter, loss. We define all those parameters, and then if those parameters are violated, or the SLA is violated, I should say, we switch the traffic over to the other link. So this is pretty neat, and I think because we have what's called DPI or Deep Packet Inspection capability, we have the luxury of using SLA compliance. Now, from a high availability and redundancy perspective, depending on how your site is set up, if it's layer 2, we can do VRP. If it's layer 3, we can use OSPF or BGP on the LAN side of the house. For transport, we can fail over any of the paths, not an issue. From a head-end redundancy perspective, we can have redundant appliances at the data center, and we can have a single appliance at the branch with multiple circuits coming in, and we can fail over either over a circuit, or we can also tolerate a hardware failure. And from a controller perspective, of course, we would want to have multiple controllers running in our environment, so we're able to fail over if any of the vSmart controllers were to fail. From a security standpoint, Cisco has, I believe, compared to some of the other SD-WAN vendors, a pretty big advantage. They have the full capability of running an enterprise firewall, an IPS, URL filtering, advanced malware protection, secure internet gateway, or SIG, and SSL proxy, all on a single box. You don't need another box. So I call that a one-box solution. So if you're trying to save money and consolidate hardware footprint, and you don't want to maintain yet another piece of hardware at all of your locations, you can get rid of your existing firewalls and consolidate that security functionality onto the Cisco SD-WAN appliances. But a quick word of caution though, if you do that, make sure you do a lot of engineering homework, and you look at the throughput and the performance numbers, and you pick the right type of boxes. Because what ends up happening is when you start enabling advanced security features, CPU starts to take a big hit. And at that point, your box is not going to perform at the marketing threshold that you see on Cisco's website, right? You really have to know how the SD-WAN appliance behaves when all the different bells and whistles are turned on, and most likely would have to go one level up, or in some cases 2 levels up, to make sure that you have the right type of hardware appliances to be able to handle the overall load. Another very important element that is very near and dear to my heart is planning the migration from your traditional WAN over to the SD-WAN. That's a big step. So how does that work? Let's look at some of the elements that we should consider before we migrate. First, we need to look at controllers. As a customer, we need to decide what type of deployment model we want to have. 99% of the customers go with cloud hosted, but if you have some strong regulations and you must have them hosted on-prem, you do have that choice, but you have to make that call ahead of time. Also, we have to decide what kind of redundancy we would want. Also, we have to look at the scale of the controllers, right? We have to look at how many sites we have and how many tunnels are going to be created, and then figure out how many controllers we would need, and then make sure we have redundancy on top of it. And from a controller high availability standpoint or redundancy standpoint, we need to make sure that not only the vSmart, but the vBond and the vManage All of those controllers are actually highly available and redundant. And finally, firewall ports. So we need to enable certain ports on our firewall to allow the controllers to talk to each other and also allow the controllers to speak to the SD-WAN appliances. There's a lot of communication that is happening back and forth with all these different network elements within the SD-WAN fabric. I will provide link in the video description, so check that out, to the firewall ports and some of the other configuration elements that you should consider. Next element is the data center. So we have to look at, do we have any new circuits in the design, or are we dealing with existing circuits? You have to look at the overall design. Are we talking full mesh, hub and spoke? You have to look at routing. We have to look at traffic engineering. We have to look at the different policy requirements, quality of service, different SLAs that we have to consider. All that needs to be taken into consideration. Same thing with the branch side. We have to see, are we dealing with existing underlay, or are we going to have new circuits coming in as part of the redesign or the re-architecture or the upgrade? Also, we have to look at the different applications and application flow. We also have to look at the design, full mesh, hub and spoke, and all that. We also have to look at the policy. Are we going to do local internet breakout at each branch, or do we want to backhaul the traffic to the data center? A lot of the customers these days are taking advantage of the local internet breakout, but that does mean that you have to really consider your security policy, because you may have a central security policy model today. You may have to look at a distributed security model. And we also have to consider access to SaaS and IaaS applications and see whether or not we can benefit from that optimization. And licensing, smart account, virtual account, make sure it's all tied together, because the entire SD-WAN fabric is kind of tied into the smart and virtual account. So it's very important that you have a grasp on that. And also the CPE ownership. In other words, who is going to be the owner of record when it comes to the SD-WAN appliances? Are you as a customer in charge, or have you hired a third party to manage your environment? If you have a managed services provider who manages your environment, then we have to take into consideration how the devices are going to be managed, and if you're actually going to hire professional services or advanced services to configure your SD-WAN, we have to look at how that ownership is going to play into the overall scheme of things. And here's how the migration sequence looks like. The first thing we want to do is we want to set up all the controllers first. Then we want to turn up our data centers. And finally, we start bringing the branch locations into the SD-WAN fabric. From a high level, kind of a super high level SD-WAN transition strategy perspective at the branch locations, what we want to do first is that if you have two sites, site A at the bottom and site B at the top, we would want to replace the internet routers with the SD-WAN appliances first and set up our secure tunnel. Then what we do is, we already have a tunnel established over the internet. We set up an extended tunnel over MPLS. So this way we have redundant tunnels. In case the internet goes down, we can continue to operate over MPLS. And then finally, this is the ultimate nirvana stage where we are completely migrated over to SD-WAN, both MPLS and internet. And that's the ideal place you would want to be. But for most of the customers, it takes a while to get to that stage, depending on how many sites you have. And the final thing I want to talk about today is the SD-WAN appliance portfolio. So for branch and aggregation, we have the traditional Cisco routers, the ISRs and the ASRs. The ISR 1000 is a small box. You can get in different form factors, like a desktop or maybe like a 1U type box, depending on your needs. And it's able to terminate a different type of DSL circuits, 4G, LTE, things of that nature, suited for small to medium businesses. ISR 4Ks, on the other hand, are suited for medium to large enterprises and branch locations primarily. And they're capable of handling voice modules and UCSE modules as well. And there's also a power supply redundancy. So you start getting some hardware level redundancy at the ISR level. And ASRs are the big boys. These are primarily targeted toward data center, HQ locations, and locations that have very high bandwidth needs. Now the box below is Viptela OS. ISR 1K is the only box that is capable of running the Viptela OS. The acquisition of Viptela allowed Cisco to inherit these vEdge boxes you're looking at on your screen. So these came from Viptela. Cisco didn't get rid of them. They're still here. You have a choice to either pick between the vEdge boxes or the ISR boxes. It's your choice. The difference being ISRs have the ability to run security, whereas vEdges do not have the ability to run security capabilities. So if you're looking to deploy security, then you need to look at the ISR boxes. Virtualization. So there are two very interesting boxes, the ENCS or the Enterprise Network Compute System 5000 and CSP Cloud Services Platform 5000. These two boxes are actually x86 type boxes that have the ability to run virtual network functions. So you can spin up multiple virtual routers and virtual firewalls and virtual WAS for optimization and things of that nature. And you can host third-party VNFs, and it allows you to have a lot of flexibility. It's primarily targeted toward edge computing model, where you have really large stores or branch locations where you need sort of like a data center type virtualization model, but instead of going to the cloud, you have high speed, low latency needs at the access level. So these boxes get you that. And finally, we have the cloud. And this is where the AWS, Azure, GCP comes into play. If you're using the traditional ISR routers or ASR routers, then you would want to get the CSR 1000V or CSR 1K to be spun up in one of these clouds. But if you're using the Viptela OS and the vEdge boxes, then you would want to get the vEdge cloud box to be spun up for you in one of these infrastructure as a service provider's cloud. And that wraps up today's video. I hope you guys enjoyed today's video. If you did, give me a thumbs up, hit subscribe, and I'll see you in the next video.